Hello all guys, welcome you back for the session on AIML where we're going to learn everything that we require in order to become a successful data scientist. Hope you guys are enjoying this series. So before going for the session, as we always ask, please make sure that you guys have watched all the previous session so that you can have a better understanding of what we are talking. Okay, so today we are just going deep into the validation techniques that we require for validating our machine learning model. So previous session is what introduction about the evaluation steps that we are having in machine learning model. Today we're gonna continue that. Okay, guys, you doesn't know anything if you doesn't watch any previous video. What context we are talking, you doesn't know. So please make sure that you guys watch the previous video and then come back and then watch this video. Okay, so let us dive to this session. So first thing that we are having today is bias and variance trade-off. The bias-variance trade-off is a fundamental concept in machine learning that describes the relationship between the model's bias, error due to simplifying assumption, and its variance, error due to sensitive to training data. Okay, so bias variance considered as a trade-off. Like it is like an underfitting and overfitting problem only. It's in a different concept. Okay, so let's see. High bias. Okay, whenever we are having high bias, then it is underfitting. Underfitting means what? The model doesn't work for the training data itself. That is, the model is simple, failed to capture the patterns. Very simple model, so that it will not applicable for the training data itself. Then high variance, it is overfitting. Okay, overfitting means complex model sensitive to training data noises. Okay, because due to the model is complex, it is able to memorize all the training data, so it becomes overfitting. So the model should not be high variance or high bias, or it should not be underfit and overfit. How the model should be, it will be perfect fit. Somewhat, I will not perfect. It will not. You should not say perfect. Somewhat not underfit and overfit. It should be fit. Okay, for the model for the data set. So low bias and low variance should be there. Optimal model. Model strikes a balance between this simplicity and complexity. It should balance everything. Okay, so hope that you have able to understand what I'm able to communicate, right? The model should be optimal. It should not have a high bias or high variance. Okay, both the things will affect the model. Okay, it should be low bias and low variance, and it should be an optimal model. Okay, yes sir, over to you.
Yes, rightly said. So variance trade-offs. So guys, it's all about, again, name suggests bias variance. If it is there, what will happen? Okay. So bias variance trade-off is fundamental concept machine learning that describes the relationship between models bias and error due to simplicity assumption. Simple, it's very simple, huh? And its variance error due to sensitivity to training data. So high bias is underfitting. So you need to now what is underfitting, you can simply understand it properly. Huh? When it is highly biased, it is underfit. Okay. Simple model fails to capture the pattern. This is how you need to remember. Then high variance, overfitting. If there is a lot of variance, the complex model sensitive to data, training data noises. Okay. That's why there is high variance. Huh? It is overfitting. So this is how you understand high bias is underfitting, high variance is overfitting. Okay, fails to capture underfitting, fails to capture the patterns of data which are very useful, and it fails to capture overfitting, uh, complex model sensitive to training data noises. Sometimes, see, I'll tell you, overfitting happens if you're not choosing the right model. That will also be problem. Right structure, like right algorithm and stuff. And also if there is a lot of noise, if data is not cleaned properly, huh? It is not pre-processed. That is why pre-processing, cleaning, EDA, all those things are very important, so that you don't have overfitting and underfitting, guys. And right, choosing the right model, that is another point. And then low bias and variance, optimal. Like what is the optimal? Optimal will be model which strikes balance between simplicity and complexity. So because your model needs to be simple. Like you can't have a complex things in because that is what is the work. We need to make things simple, but it needs to also learn from the complex data. That is the work. But otherwise, human beings will do that work. Why we need these high computing power machines or algorithms and all these things? So we need to strike balance. The model will be balanced is which is good with simplicity and complexity. That is the very important thing. So that it is optimal, it will strike balance between both. So overfitting and underfitting and biasness only happens, guys, because of I'll say you have not collected the right data, maybe you've not cleaned the data properly, you've not done the pre-processing properly, or you have not selected the right models because you don't know which model to do what. It's like toolbox in your house, you don't know. There are thousands of tools, but you don't know which one to use where. So you're like blind. No, you don't know where to use which tool, right? If suppose I'll take you to a hospital and ask you, okay, I'll take you to the best surgeon of the hospital. I ask you, okay, use these tools on some patient. Will you be able to use? No, because you don't know. You are not done training. You don't know how, you have not studied for 6 8 years continuously because you have not done training. So how can you do training if you don't have a clean data? Like I'm giving another correlation here. So you need to have a clean data, pre-processed data, right models. You need to know in and out or 360-degree all the models which are useful. There are thousands of models, but you need to know which are working, which are well known, which are used in the industry. You need to know those models in and out, and you need to know how to collect data from right source, how to process, clean it, how to process it, how to do EDA, all those things, choose right models, then underfitting, overfitting will not happen. Okay? Because those are the elements for underfitting over. And then you know what is the balanced model, how to create, which can work with simplicity and complexity. That's it. It's very simple. So let's move to the other slide.
Yeah, sure, sir. Actually, sir has explained in a like now itself in a depth-wise manner because like that's very important. That's the reason sir is explaining this myth. You guys need to understand what is underfitting and overfitting, and you guys need to avoid whenever you are just training the model. Okay, then only you can get a perfect model that can predict the unseen data. Okay, so that's great explanation, sir. So moving on, let's see what we are having next. Yeah, hyperparameter tuning, guys. This is also one of the I love this very much because whenever you are just tuning your model, it will create some kind of fluctuation in their accuracy. It will be high or it will be low. Some kind of fluctuation will be there. So parameter tuning, hyperparameter tuning. Let's see. Hyperparameter tuning are the parameters that are not learned from the data but are set before the training process. Hyperparameter tuning involves adjusting these parameters to optimize model performance. I will put it in a simple manner. We are having random forest, right? I hope you guys have understand random forest. It is like, I think, if I'm not wrong, it is 5 to 6 session before. I will say in a simple manner, random forest is a model which is a collection of decision trees. Okay, hyperparameters means you can specify number of decision tree that you need in order to build the random forest. Okay, I will say 10 trees and I will train the model. I will get the accuracy. If it is less or high, I will just fine tune it. Okay, now I will say 20 trees or 5 trees. What is accuracy? Like that. This is what the hyperparameter tuning. I hope I have explained in a simple manner. Okay, yeah. So what are the techniques that we are having in hyperparameter tuning? First is grid search CV. So it's a package that is available, readily available in SQL, only one line of code. Evaluates a predefined set of hyperparameter combination. So we will give the hyperparameters there, and it is like a for loop, and it will run the model for that. Random search randomly samples hyperparameter value within a defined range. So we will have the we will give the range of value, and based on that, it will create the hyperparameters. Finally, gradient descent. Okay, uses optimization algorithm to find optimal hyperparameter value. So gradient descent is where this is what we used by the sklearn library, where all the model will use the gradient descent to find the best optimal like algorithm for the data set that we are providing. Okay, guys, just put it in a simple manner. Hyperparameter tuning is that fixing the parameter now to make a model more accurate. That's it. Okay, so yeah, yes, sir, over to you. Yeah, that's a major thing. Okay, like hyperparameter tuning is like that's what the concept. Okay, whenever we are just
Yes,
tuning our
yes.
model so that it becomes a good result. Okay, yes sir, yes sir. What you go ahead,
So,
please.
see, hyperparameter tuning is, if again look at the word hyperparameter. Hyper is always different parameters. Hyper means different parameter, lot of parameters. Tuning. We do tuning on that. So what we do, hyperparameter tuning is not are not learned from the data but set before training process. We have to do it before that. Hyperparameter involves adjusting these parameters to optimize model performance. So we always use hyperparameters when, suppose, what you have done is you have evaluated the model. You collected data, you cleaned data, data is from the right source, you cleaned it, you processed it, you did pre-processing, you did ADA, you selected models, you did everything is great. And then what, when you run the model, you trained and tested, and then your model is not performing well. So now you need hyperparameter tuning. So you need hyperparameter tuning so that it can optimize the performance. So you'll try. You'll do grid search. That is one of the grid search evaluates predefined sets of parameter combinations. So it will help you to uh, do hyper parameter tuning. Then there is a random search. Random search is another randomly sampled hyperparameter value within defined range. So it will try to help you and make your uh, hyperparameter tuning and performance of the model better. Okay, gradient descent. This is another um, hyperparameter tuning aspect, another kind of technique in the hyperparameter tuning. So using optimization algorithm to find optimal hyperparameter value. So already trained models are there, like already optimization algorithms are there. So they help you with gradient descent, right? They are already been trained, yeah. So they will help you. They are optimization algorithms. They are used for hyperparameter tuning. So hyperparameter tuning values. So this is how, whenever your model is not, suppose you did all of this, still your performance of model is not up to the mark. So you have to question your data source first. Question data source. Is it from the right data? Because guys, again, you will do a lot of hard work, pre-processing, cleaning, EDAs, model selection, a lot of things. So that is why, first thing first, you need to question your data source. If you're satisfied, come to data cleaning part. Go and see and see again the values. Run certain libraries, certain functions in Python or Google Colab. See again the values. See, is your data connected with the Colab or Python notebook or whatever you are using, whatever this tool for your model. Okay, so check that. So again, and then go and see, have you done pre-processing properly? Are you getting, so print those values and get data visualization, do EDA and all, do data visualization, how your data looks like. Or if that is not working, go have a look in the data, raw data file, and see how it looks like. Is there something missing? So check all missing values, all the things which are not okay. So once that is done, then again come and select some other model, select some other which is relevant other algorithm or model for your data, and then see, do all the process evaluation, all those things. And then if still that is not working, then do hyperparameter tuning on that also. So you have to do a lot of iterations to get the best performance, guys. That is the main moral of the discussion here. Okay, until unless you. So I did one of the project, guys. So I did 50 iterations to improve just 0.05% of the model. So it's very difficult when sometimes model gets stuck. so it will not move on. So sometimes, like, but I got 91.05% accuracy for that model, and I was sixth globally. Globally, I came sixth. That was a hackathon, some project. So I came sixth globally in 250 people. So, so I'll not sleep till 3 a.m., 4 a.m. So continuously, I'll until unless I get the result. So keep doing this. This is a cycle, and check where you're making mistake, where is the missing value, where is the inconsistency in data, and that will build a great wisdom in you. Huh? That is what is experience. That is what is wisdom, and that will take you far, far, far. And keep learning continuously. Watch all the sessions 5 to 10 times. Do reinforce learning, absorb the information, digest the information, and apply the information. Do all the assignments, and subscribe to our channels, and press the bell icon so that you get notification. Keep learning deeply. Thank you so much. Let's move to the other.
Yeah, moving on to the next slide. So yeah, next is evaluation metrics, guys. So I think Sir has explained in a better manner the which we have shown before, like this hyperparameter theory. So moving on, we are having evaluation metrics. So evaluation metrics are used to quantify model performance based on specific criteria. Different metrics are suitable for different tasks, datasets. Commonly used metrics includes accuracy, precision, recall, and effort score. I think we have already seen this for classification problem. Okay, it comes under supervised learning. So that's the reason, guys, we are just mentioning and insisting you guys to look into all the previous videos so that you can have a better understanding of what we are talking about. Okay, yeah, we will just go through again. Okay, accuracy, the proportion of currently classified instances. It takes off all the instances that we are having and we will calculate the accuracy. Okay, precision, the proportion of correctly predicted positive instance among all the predicted positive instances. Consider only positive instances. Whereas recall, the proportion of correctly predicted positive instances among all actual positive instances. This is what the only difference. Predicted and here actual. That's what the difference that we are having in precision recall. Whereas F1 score, it's a harmonic mean of precision recall. I don't know, like this is the same definition we have just mentioned in the classification problem. So that is what the evaluation metrics that we are having for in order to evaluate the model. So I don't think further explanation are needed. If you guys stuck here, just go to the classification problem that we are having in one session on supervised learning. Make sure that you have understand that and come here and just look into it. If you guys further doesn't able to understand, just ping us in the comments. We are here to help you. Yes, sir. Over to you.
Yeah. So evaluation metrics, guys, we have to we use these metrics to quantify model performance based on specific criteria. Different metrics are there for suitable, like different tasks. There are different metrics for different tasks. So and data set. Commonly, we use these metrics for accuracy, precision, recall, and F score. Accuracy is for proportion of correctly classified intensity. Correctly classified. That is what you need to understand. Accuracy is for correctly classified instances. Precision is portion of correctly predicted positive instances among all predicted positive instances. Only from the positive, positive from the positive. Okay, that's what you have to understand. That is called precision, positive from the positive. And then predicted, correctly predicted positive instance among all the predicted positive, only positive. Definition says positive, no negative here. That is what is the precision. Recall is it's not that precision, guys. In general life, we use precision. Here, definition is different. It is for data, okay, for machine learning, because we can't give a lot of parameters for machine learning. No, machine is designed for binary 0 and 1. So every architect, whatever we design or applications, it is fundamentally depend on that. So it should be so simple that machine should be able to understand. Okay, that is why here you'll find some difference between the general definitions what we use in real life and what definitions mean here in computer science and AI ML data science. Okay, recall is proportion of correctly predicted positive instances among all actual positive instances. Okay, so there's a very thin line. You have to understand deeply the words definition here according to computer science and AIML data science. Okay, not your general. So recall here is predicted, correctly predicted positive instances among all actual positive instances. That is what is recall. Okay, so then we have F score. We use it harmonic mean of precision and recall. So F score balances recall and precision, guys. So it will help us it predict the positive instances among all predicted positive instances and uh, predicted positive instances among all actual positive instances. There's a difference. uh, See, you will find little confusion in precision and recall. I'll just clarify. I'll take 1 minute. The the precision is simply the portion of correctly predicted positive instances among all predicted positive instances. Whatever is being predicted, okay, that from that whatever positive instances are coming, that is precision. So now recall is predicted positive instance, correctly predicted positive instance among actual positive instance. That is the difference. The actuals are different, predicted are different, because see, actual will be from the entire data and predicted are which has been predicted by the model. That is the difference, guys, and that is why precision and recall makes difference. So otherwise you will see like both definitions are similar, but actual makes a difference. Actual is the actual data which are actually in the data set, which are with whatever pre-processing everything you have done, from there the positive. But here all the predicted which model has predicted. So that is the difference, precision and recall. And F score does whatever is actual. F score helps the precision and recall, but actually recall and precision is what? Actual positive instances and predicted. So that is why F score is very powerful. You will see when you use F score, you will have a balance kind of thing. And when you use precision, you will have one-sided uh, view kind of thing. But when you use recall, it will have other side. And that is why scientists have developed F score so that it balances precision and recall. I think it is very simple now. I made it very clear. What is the difference? So let's move to the other slide.
Yeah, sir. Actually, it's like clear and nice. Okay, like now the like no one will have a doubt. Okay, if you have a doubt, just look into the session. If you have further, just ping us in the comments. Okay, we are here to help you. So moving on. Okay, guys. So finally, we are having model selection and comparison. So model selection involves comparing performance of different models on given task and choosing the best model performing model out of it. Okay. This involves evaluating model using appropriate metrics and considering factors such as model complexity, interpretability, and then computational resources. These are the things that we are having for model selection. Once we have the model is ready, we need to select the model based on our data set. Okay, that's a major thing. Okay. Model training different model using various algorithm and hyperparameter selecting. That's a major thing, guys. So you need to train your model, and as well as you need to fine tune your hyperparameter so that you can get the better accuracy. Next is evaluation. Evaluating the trained model using the appropriate metrics and comparing their performance so that we can understand whether our trained model can predict the unseen data. That for evaluation. Selection. Choose the model that perform best based on the evaluation criteria. Okay, once we have trained the model, we need to train with various algorithm, and we need to evaluate the model, what model best fit for the unseen data. Once we have done it, we need to go for the selection, which model perform best on our evaluation criteria. So I think this is a comprehensive thing that we have done till now. Okay, so yeah, that's it for this model selection and comparison. Yes, sir, over to you.
Yeah, so model selection and comparison. So let us focus on model selection. Model selection helps us comparing the performance of different models on the given task or choose the best performing. See, guys, when we are evaluating, we need to evaluate on different models which are relevant. So that we'll choose the one. That is what the model selection means. That we have to choose the best performing model on our data. Whatever data we have collected, we have cleaned, we have pre-processed, we have done EDA, we have selected the model, we have done everything, and then we have to do it. We do three, four iterations on different models. So then we do model selection. Okay. Then we have to evaluate model on different metrics, factors, model complexity, interpretability, computational resources. So you cannot use a model which will require billions of data computations, right? So you have to understand, you have to see that how many GPUs you need, how many like how much computational power you need. Ultimately, it will come there. So you have to interpretability, you have to see complexity. So model training, train different models using various algorithms and hyperparameter setting. So that is what I was saying. First train on different models and algorithms so that hyperparameter setting, so that you know you will have best one to choose. Okay. Evaluate the trained model using appropriate metric and compare with the other performance. That's what you have to do. Evaluation is always done on a different variable, different models, right? You have to do evaluation based on that. So then you have to choose the model which is perform the best. Okay, which is the best based on evaluation criteria. So based on precision, all the like accuracy, performance, all those things, parameters, whatever are the parameters, based on that you choose the best one out of, suppose you have trained two, three models on the data. So now you have to evaluate, then you have to select one. Okay, this is the best. So you have to then make a report and make a good written report. Okay, and then you have to submit. Yeah, thank you. Let's move to the other session. Yes.
Yeah, so yeah, guys, this is what we are having for this data evaluation, that model evaluation and validation. Hope you guys have enjoyed this session. So, guys, this is very important. Make sure that you guys have watched previous videos so that you can make an understanding of why we are just talking about this model evaluation this much. Okay, whenever you are just going for model training, you need to evaluate the model which for the unseen data so that you can have a perfect model. I will not say perfect. You will have a like better model, an optimal model to do the prediction task on the unseen data. So this is what all we are having for this session, guys. So hope you guys have enjoyed this session. Till next session, bye guys, take care, and we'll meet in the next session. Okay, bye guys.
Yes, so guys, again, I will reiterate, go watch all the sessions 5 to 10 times. Don't come to, if you have come to this session, go back, watch all the sessions. You will understand what we are talking. Otherwise, it will go above your head. So, absorb the information, digest the information, and apply. Do all the assignments and write down in the comment section what have you learned, what is your objective function, long-term objective function of your career, and also do all the assignments and press the bell icon so that you will get notification for each session, and also subscribe to our channels so that you will be connected with us. So thank you so much. Keep learning deeply with persistency, consistency, and patience, and build long-term objective function for your life career so that you will become a lifelong learner. Thank you so much. See you in the other session.
Yeah, guys, bye. See you all in the next session. Bye, guys.